Good morning, sir.
Hi, my love. I made a big boo-boo this morning. Just send a message to the others and tell them say you're in this session, please, because I just made a big boo-boo.
Yes, sir.
Thanks. Hey, guys. How you doing? Good?
Yes, sir.
All right. Morning, see Papa Malik. Um, I would want to tell you what happened here. Danica, what happened to you? Oh, when they're school? Yes, no. I said it Tony together. Hey, hey. Mix up. Story come to bomb because some people say, sir, I have to go home. I can reach home in half an hour. I see where you are. All right, Papa. Now I've nothing more to say. All right. Oh no, sorry, Abby. I tell you, you must take a vitamin C. Trust me. I'm still struggling with my one, but I'm feeling more every day I feel a little better, but it's the symptoms are still there. All right, just get well. Just get well, guys, please. All right. Uh Never mind. Get some room temperature water done. Waiting on somebody. You know what? Um, I'm gonna behave myself here because I'm being recorded. I will talk to you about this in person. All right.
Sir,
Yes.
listen to me now.
What is wrong with you? What is wrong with you? Yes, Randy, story come to bomb. They said to me, sir, don't keep no class, not this time, 11:30. You see what time is it now? 11:48. and school finish from 10:30. All right? Never mind. Guys, little laugh better than quarrel, yeah? We have to enjoy ourselves where we learn. All right. So Malik sent me a past paper. However, the paper that he has sent, I am not right there just yet, it's not a bad paper, but I don't reach, well, we did the differentiation questions. I don't reach double integration, so I can't do that. Stationary points I don't reach yet. I'm getting there. There's some other differentiation questions there that maybe we could do those too. And there are some multivariable functions that we do. Oh, yeah, man. I buck up 3 integration question. All right, we're good then. Share screen. When I looked at it earlier, I didn't say anything that we could work on, but we're going to do share screen here for the time that we have. How do I do this, Lord? How do I do this? Is there a blank page? I don't have much of a blank page here. All right. You see all this question 4? You see, if we go to the exam and see a question like this, when you just start say, "Jenko Jesus, me come back," then you can finish the exam and go with a good sleep and wake up, and then still exam still go on. Easy, 1, 2, 3. Easy, 1, 2, 3. So we're going to do the first part of this question, part A, and then I'm going to do part C, the differentiation. Those parts are not bad, but we don't reach here. This is an integration question, but it's a double integration, and I don't reach there so just yet. So let us just get the ball going by looking at these 2 differentiation questions. Trusting that the rest of you are okay and that wherever you are, I'm still going to be as close as possible to our agreed time for 12:30. I apologize again for the mishap earlier, but it worked out for what it is. All right, so let us look at question 1. Question 1 says, is it okay for me to work it right here?
Sure, sir.
All right, good. So for this one, this is a product. This is my first. This is my second. So this is a product rule. I'm using a product rule there. And so let us look at the first one. It's going to be the first. So f dash of x is going to be the first, which is 4x cubed plus x squared, the first, times the differentiation of the second. Is the second a power? Is the second
No,
a
sir.
power?
No, sir.
No, it's not.
No,
Very
sir.
good. Very good. It's not. So times the differentiation of the second, which is thus, what is it?
2x.
Very good. Times 2x plus the second, x squared
X squared minus 3.
right. And the differentiation of the first. No, when you differentiate the first, what do you get?
12x squared plus 2x.
Excellent. 12x squared plus 2x. All right, good. So just remember, the power rule deals with when you have something raised to a power greater than 1. Both of them are raised to the power 1. Both of them are raised to the power 1. All right, so it's the first times the differentiation of the second plus the second times the differentiation of the first. So all of this now is going to be equal to, let me just rewrite it nicely. 2x times 4x cubed plus x squared plus x squared minus 3 times 12x squared plus 2x. And I'm going to distribute one over the other now. I'm able to distribute it because the powers are 1 overall power. 2x times 4x cubed goes 8x to the fourth, don't?
Right, sir.
All right. You notice why I'm doing the distribution here? Look at it. I am doing the distribution here because there's nothing common that I can factor out. Can you agree with me?
Yes, sir. Yes.
Right. So 2 times 4 is 8, so 8x to the fourth, and x times x squared goes 2x cubed. So this is plus 2x cubed. And then this one is a long one now. So this is a x squared times 12x is going to be 12x to the fourth plus 12x to the fourth. And x squared times 2x is going to be plus 2x squared, cube. And then negative 3 times 12 is negative 36 x squared. And 3 times 2 is 6 minus 6x. Tell me if my multiplication is off or is correct.
So it's correct.
Nice job. All right. So what I'm saying here is what I'm saying here is so let me just do the multiplication again for those of you who may not have seen it. 2x times 4x cubed is 8x to the fourth, which is right here. And 2x times x squared is going to be 2x to the third, which is right here. And x squared times 12x squared is going to be 12x to the fourth, which is right here. X squared times 2x is going to be 2x to the third, which is right here. And negative 3 times 12x squared is negative 36x squared. And negative 3 times positive 2x is going to be negative 6x. I'm just grouping them via like terms. So I'm looking for the x to the fourth. So 8x to the fourth plus 12x to the fourth is 20x to the fourth. Now that I'm finished with x to the fourth, I'm going to x to the third. I have 2x to the third plus another 2x to the third. That's 4x to the third. I don't have any more, so I'm going to write down my 4x to the third. Then I'm going to go to the second. No second, no second, no. I have no second. I just have the negative 36x squared. So I write back and then negative 6x. So that would be the answer. Those are my 4 marks. And incidentally, let me show you how you can get the 4 marks for that. You get 1 mark for here, 1 mark for here, 1 mark for there, 1 mark for there. And that's where you get your 4 marks. So if you made a mistake with one of the signs, it's only 3 marks you can get out of the 4. Any questions?
No,
Are we
sir.
okay? Are we okay?
So saying to get marks, what they're working on.
No, you don't. No, it's because it's 4 marks. They're just going to give the mark for the answer. So they're just going to give the mark for the answer. So you have to evaluate the stuff properly and carry it all the way down to the end. Now, if I am marking it and I see where the differentiation would have ended right here, so if you've done this part, I would give you a follow-through mark, a FT mark. That's what the mark for CXC. I'll give you a follow-through mark, maybe for 2 marks. So I'll give you 2 out of 4. But really, and those are the follow-through marks if you didn't do anything else. But the 4 marks would be for the 4 different answers down the bottom. Any other questions?
No, sir.
Sorry, somebody was saying something else? Randy, was that you?
No, sir.
All right, somebody was coming in. Somebody else was coming in. All right, I heard no one, then I hear another question. All right. So let's go to the second part of the question. Let me see if I can put it here. The second part of the question says f of x is equal to the root of x squared plus 1. And remember now, we can rewrite this as x squared plus 1 raised to the
Half.
Half.
very good half power. raised to the half power. Excellent. Raised to the half power. And of course, this is going to be my power rule now. So it's going to be f dash of x is going to be equals to a half times x squared plus 1 to the negative a half times the differential of the inside, which is going to be 2x. So that one is easy. 2 times a half times 2x is just going to be equal to x times x squared plus 1 to the negative a half. So f dash of x is going to be equals to x over the root of x squared plus 1. And that's my answer. Look at that and tell me if you agree with it.
Yes, sir.
Any questions relating to that one? Talk to me, guys. Any question? I don't understand though. What I don't understand is why would they give 4 marks for question 1 and 4 marks for question 2 when question 1 is a longer question than question 2? That don't make no sense. I would have given the worst case scenario, I'd have given 5 marks for question 1 and 3 marks for part 2 of the question. But anyhow, it's not my paper, it's not my thing. So if I were marking this, I give you 1 mark for the numerator, 1 mark for the denominator, and give you a mark for having this and a mark for having the differential of the inside of the parentheses. Any questions?
No, sir.
All right. Sorry, there is. All right. Which one do you want me to go over, Danica? Rian, the paper that you had found, Rian, is the same one that Malik had?
Sir,
Say it again, Rian.
sir, yeah.
Oh, okay. Sorry, Danica, you're saying the one you just did. Okay. So I'm being asked to go over this one here, the one we just looked at here. So remember what we looked at just now is the square root rule. So once you have the square root, what we're going to be doing is to convert. And when we convert the x squared plus 1, the root of x squared plus 1, we're going to have it as x squared plus 1 raised to the half power. X squared plus 1 raised to the half power. So that's a conversion. Now, chances are they may give you 1 mark for doing that, for doing the conversion, for recognizing the conversion. And then when you differentiate it, this half, my spotlight is somehow not working for this PDF document. No, it's not working. It's only up top. It's not working on this. Anyhow, so it's going to be this 1/2 that is going to be multiplied in front of the x squared plus 1, which is what I have right here. And then we're going to write by the x squared plus 1, and then we're reducing that power by 1. Remember, when we reduce by 1, it's going to be a half minus 1, which is going to give me minus a half. It's a half minus 1, which will give you minus a half. It's going to give minus a half. So I write the power to minus a half. And then what is important, very, very important, is that I have to differentiate inside of the parentheses. That's what is important. I must differentiate what is inside of the parentheses. If I don't, my question is going to be incomplete. Incorrect, incomplete. Wrong up, wrong up. So I have to differentiate what's inside the parentheses. All right? And then what I'm going to be saying is 2x times a half is going to give me x. 2x times a half is going to give me x. And all I do is just multiply the x by the x squared plus 1 to the negative a half. Remember, we never normally write or or answer as a negative index. We never normally write our answer as a negative index. So what I want you to do is to convert that negative index into something that is positive. What do? We reciprocate. How do we reciprocate? We just put 1 over the x squared plus 1, and that becomes positive a half. And then that positive a half now is going to be converted as a square root. Fair enough, Dan? Okay.
Sir, can you please repeat that, please?
No, I was just asking Dan if she's okay with that one. She had asked me in the chat to go through something. So are there any other questions? She answered me and said yes. So I'm asking the class now. Are there any other questions relating to that? Are you understanding? Is it okay? You want me to do something else? What is it? All right. No question.
Sir, wait. How would you approach it if you had a whole number in front of it, the question?
If I had a whole number in front of what? In front of the square root
Equation.
sign?
Yes, sir.
Same difference. I could use a product rule. So let me generate something based on your question. The question is, what if I had a number in front of it? Okay. Say, let me give an example. Say we have f of x to be equals, what whole number you want? 5? 5 times the root of x squared plus 1. That's okay?
Yes, sir.
All right, good. Not a problem. So I'm still converting. And the conversion there is going to give me 5 times x squared plus 1 raised to the half power. Still, it's still going to be the product rule because I have a number here multiplied by that. Or I could just, or somebody's in the waiting room. Hold on. Let me just clear this person from the waiting room. So what I could do is I could differentiate. When I differentiate all of this now, this half is going to be multiplied by this 5. So it's going to become 5 over 2. 5 over 2 times x squared plus 1 to the negative a half times 2x, which is the differential of the inside of the parentheses. And then what I'm going to have from there is going to be 5 over 2 multiplied by 2x over 1 times x squared plus 1 to the negative a half. This 2 cancels that 2, so I'm going to be left with 5x over the root of x squared plus 1 as my final answer. So it works. It works. It works. However, wherever. The only thing that is just like it's just like you're differentiating 5x squared. The 2 is going to multiply by the coefficient of what is in front of that. Because really and truly, was that Abigail who asked the question?
No, sir, me, Lisa.
Okay. So Lisa, look at what is happening here, hon. It could be the same thing as having a 1 in front of this, right? And then I convert it and I put a 1 right here. So So a half times 1 is 1. And then now a half times 1 is 1. Ha ha ha. A half times 1 is a half. So you see I get the half right here. So it's pretty much the same thing, Lisa. It's pretty much the same thing. Nothing to really worry about. Real and true. Nothing to really worry about. All right. Any other question?
No, sir.
All right. Let me tell you what I'm a little worried about. I'm a little worried that there are some of you here who just not follow what one. I remember, you know, this is a little makeup class, a little past paper session, so forth and so on. Because remember, the school closed 12 o'clock today, you know. And my class would have started 1 o'clock. So technically, I'm not supposed to have class with you today. But I said, no, let us put in a little past paper, something, so we can just do a little 1 or 2 things. So students, I say this to say to you, let us make good of this exercise. All right, please don't just sit down here and just be a spectator. I want you to become an active participant. All right, so let us jump to question 4A. Let us jump to question 4A. Let us jump to question 4A. Question 4A says we're going to integrate 2x cubed minus 3x squared plus 1 dx. Remember, the rule says add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. It is no biggie. I will never tell you something that don't go right. I will never do that. I promise you. I will never ever do that. All I'm saying to you is the same thing. It is the always adding 1 to the power, divided by the new power when it is that we are integrating. Always adding 1 to the power and dividing by the new power. Always add 1 to the power, divide by the new power. So let's go. Adding 1 to the power, divide by the new power. 2x to the 4th over 2 minus 3x cubed over 3 plus x plus c. This 2 cancels that 2, this 3 cancels that 3. So my answer is x to the 4th minus x cubed plus x plus c. Tell me if you agree with me.
Sir,
Yes, my love.
you can repeat that, please?
What do you want me to repeat?
Like, go back over everything.
I'm adding 1 to the power and I'm dividing by the new power. I'm adding 1 to the power and I'm dividing by the new power. I add 1 to the power and I'm dividing by the new power. So what I'm doing is, it says 2x cubed, I'm adding 1 to the power. 2x cubed, I'm adding 1 to the power, 3 plus 1 is 4. So it's 2x to the 4th over 4. So I might have 2 right there, so, and I'm not
Sir,
telling
I
you.
have two, yeah. Sir, that's why I say we are do if I have 4 this so.
But when you sit down and put answer me have 2 there and another don't tell me nothing. What is wrong with you now?
If we go back over it, sir, can me confused.
Sure. See the I put that there and not said it's supposed to be to the new power, which is 4. Tell me, say understand that now. Yes, no?
Sir, where does the plus
Yes,
x
sir.
plus come in?
Where does what come in?
Plus x plus c.
When I integrate 1, I get x. Remember, recall the integral of dx, we don't say 1 dx, is going to be equals to x plus c. You remember the rule that I gave you?
Yes, sir.
Yeah, man. Hit that.
Sir, so see the constant.
Of integration every single time, yes. Every single time. Talk to me. Any other question? Are you seeing what is happening now? So remember, the mistake that I made is that I put 2 right there, but it's always adding 1 to the power divided by the new power. Talk to me now, guys.
Yes, sir. That one was all right.
All right, sir.
Good. All right, good. So let us see if we can move now into the other question. Whoa, hold on there. Did I teach you how to integrate the exponential function? I dare somebody say no. I want one of you to tell me no. Because if you look back at this stuff, you will see.
Rule 5.
Say it again, Randy.
I think it was rule 5.
Right, because it was on the paper. And this is a simple one. The integral of 2e to the x plus 3 over x dx. All right. Now, what it is that we're going to be doing is integrating individual terms. We're going to be integrating individual terms. So when I integrate e to the x, the integral of e to the x is e to the x. The integral of e to the x is e to the x. The integral of e to the x is e to the x. Sir, how do you know that? Remember I said to you, when we integrate, we are going to differentiate the power, differentiate the power, then reciprocate. Remember?
Right, sir.
The example that I gave you, recall the example I gave you was e to the kx, and the answer was 1 over k e to the kx plus c. Talk through. Look at the rule and tell me if that's it, if that is it.
Yes, sir.
Yeah, man. Remember, no students. It's what, sir? Why am I having this class? Time is of the essence. The business calculus is long. It is fun, but it is long. All right. So you have to, you can't. Sure, I mean, it is long, and we have to, when I give you a handout, you see what I did? I didn't waste time to write the handouts on, not the handout, rubbish. Didn't waste time to write the rules on the board the other day. I went and did copies for you because of the importance of having all the rules one place, right? So it's important that you go through the rules. So what that rule is saying, the integral of e to the kx is going to be equal to 1 over k e to the kx. It means that the integral of the exponential function is the exponential function itself. However, I must differentiate the power and then reciprocate it. So when I differentiate kx, I'm going to get k. And when I reciprocate k, I'm going to get 1 over k. And then I multiply the 1 over k by all of that. Now, when I differentiate x, what do I get? Oh, that wasn't a trick question. You know, when I differentiate x, what do I get?
There 1 over x.
Not 1 over x. No, man. I'm differentiating the function. When I differentiate x, what do I get? Guys, when I differentiate x, what do I get?
X,
What? Say it again.
there 1.
Yes, not no 1, man. And 1 over 1 is the same thing as 1, don't?
1.
Yeah. You follow me? Somebody talk to me now, please.
Yes,
Yes.
sir.
Yes, sir.
Yeah. All right, hold on me, please. All right. Now, let me do this one a little trickify way to see if you guys can understand. I'm going to do this one. So how it come on? I know I don't understand this thing, you know. Oh, so it doesn't work with the pen, but if I use the thing, it works. Okay, I learned something now. I learned something now. All right, so where was I going? Let me use this one here. I'm going to use this one here as a product. Well, let me not say that. Scrap that. That's not what I meant to say. What I want to say to you is that remember the rule when I'm integrating, I can take what the constant and just integrate the function.
Yes, sir. Yes, sir.
Good. And then now, when I integrate that now, so it's going to be 2 times, and the integral of e to the x is simply e to the x plus c. So this piece here, the first piece is going to be e to the x plus c, right? And of course, that will work out to be, well, let me not even work out that part here, because there's something that I need to show you based on what I did the last time. All right, so let's go now. And then now I'm going to integrate 3 over x dx. But 3 over x dx is the same thing as writing 3 the integral of 1 over x dx. When I integrate 1 over x, what do I get? Look at the paper, no man. Nothing that I'm doing here is new, you know. When I integrate 1 over x, what I get?
X to the -1.
1 over x is the same thing as x to the -1. When I integrate x to the -1, what I get?
1.
No,
NX.
ln x. Say ln x.
So ln x.
Yeah,
What is
man.
it? Say?
Yeah, ln x. So it's going to be ln x. So, so that we're going to work out to be 3 ln x plus c. So combining these two will give me my answer as 2e to the x plus 3 ln x plus c. Remember the law that says when I'm integrating, I can integrate individual pieces, but
Right.
what is happening now? This plus c right here, so with this plus c still give me a c.
So the c is constant, so,
The
right?
c is a constant, yeah,
Right.
yeah. So what I'm gonna have is, remember, the integral of e to the x is e to the x. So this 2 is my constant, so I can multiply, so I can get 2e to the x. Don't say plus 2c, because it is, even if I have 2c, and I'm going to have 3c here. 2c plus 3c is 5c, but 5c is still a constant. So this is going to be my answer for part 2 of the question for 4 marks. Look at it and tell me if you are seeing it, if you agree with it, if you want me to talk to you about something else to relate the laws that we looked at. Let me know.
Sir, you can go over it one more time, please.
All right, so what is happening is when we integrate the exponential function e to the x, it's going to be e to the x times the differential of the power, and then you're going to reciprocate it. And then you're going to reciprocate it. But it so happens that the power is merely x. So when I differentiate x, I'm going to get 1. And 1 over 1 is the same thing as 1. So it so happens that the integral of e to the x by itself is just e to the x. And then when I multiply it by the the 2, I'm just going to get 2e to the x. Similarly, when I integrate 3 over x, 3 over x is the same thing as just writing 3 times the integral of 1 over x. Well, the integral of 1 over x is ln x. You have to remember these laws. Sir, you can get the formula sheet in the exam? No. You have to remember these laws, and that's why I go ahead and type it out for you now. It's not because I don't have things to do. I make sure I sit down and type it out for you so that you can have these laws in one place. And what I did for the differentiation video, I give him a song. So you can sing a song while you're doing a differentiation. You can't go wrong. Can't go wrong. All right, work with me. So when I multiply here, 2 times e to the x is going to be 2e to the x. And 3 times ln x is going to give me 3 ln x plus c. A constant is a constant is a constant. So once I have my plus c, is to multiply this 2 by this c to give 2c, and this 3 by the c to give it 3c, and you're going to get 5c, it is still a constant. It is still a constant. All right? Any other question?
No, sir.
All right, do me a favor. I'm going to ask you to evaluate part 3 for me. What is part 3? The integral of 5y cubed dy. Sir, the question can't work because the one you said dx, sir, and this one said dx, and this one said dy. Yeah, but remember, said the one you said dx. But remember, the variable inside of the function is x. That's why this is dx. This one said x because the variables inside of the function is x. The one is a y because the variable inside here is y. So them couldn't give you dx and give you y in the function here. So that couldn't work. So whatsoever d of what it is going to be the variable of what is on the inside. Does that make sense?
Right, sir.
Go ahead and differentiate that one for me, please. Talk to me. Finish? This one is the easiest of them all, you know. So it should be finished by now.
Yes, sir.
What do you get for the answer?
Sir, I got 1.25y to the 4 plus c.
Why don't you convert to decimal, so? You don't give me as a decimal. Give me something without decimal. Come on.
Sir, so it would be 1 and 1 over 4 y to the power of 4 plus c.
All right, so you're correct. Everybody agree?
Sir, I agree. I got that.
Well, don't try to convert. So this is what I am going to do for mine. I'm adding 1 to the power, dividing by the new power. Answer. Done. 5x to the 4th over 4. I'm not going to put 1 and 1 over 4. 5y to the 4 over 4 plus c, done. I don't know why they give 3 marks to that door. Like, seriously? That is not even 3 marks. Talk to me if you agree with what I have. You're adding 1 to the power divided by the new power.
Yes, sir.
Right. How we
But
feel?
say,
Go ahead.
so me I say for the answer, sir. So me have to work it out, sir, to show say that the answer, or me can just drop that down and just
Alright.
call it that day.
Call it a day. You don't need to do nothing at that, Papa. Call it a day. Done. Finito. You add 1 to the power divided by the new power, done. If you want to check it, if you want me to check it with you, no, I can show you. So that is the answer. Watch me. Remember, 5 over 4 is my, so I'm going to let y be equals to 5 over 4 y to the 4th. 5 over 4 is my constant, so I'm going to leave that alone. Then I'm going to differentiate y to the 4th. When I differentiate y to the 4th, what I get? Talk to me now.
Four y to the 3.
Thank you, my love.
4y cubed.
4y cubed. So 5 times 4 over 4y cubed. That cancels that, equal 5y cubed. What more you want, Manik? You see the point I'm making, Papa?
Yes, sir. See.
Right. So this is my integral. So you can see the opposite in it now?
Right, sir.
Right. So the integration versus my differentiation. So if you want to know if the answer is right, it does differentiate the function. And you get back your answer. And you're good to go. And you're good to go. All right. So we did agree that we're going to do at 12:30. It's now 12:35. I'm going to hold you accountable again. Apologies for the mix up with the link. Thank you for coming out. We did some questions. We did 6 questions. No, yeah, we did 6 questions, 3 right there, 2 up there, and then Lisa asked me to make up 1 right here. So so we did 6 questions. I think this is good. Do you want me to send you this this document here so that at least you can refer to the questions on it?
Yes,
Or you're
sir.
fine?
Yes, sir. Yes,
All
sir.
right.
Yes, sir.
So let me
Yes, sir.
save the document and then I will send off to you. Hold on, let me just make sure that I have, so that I don't. Check to see if you've gotten it for me, please, because I don't want to leave and then I don't do it. And make sure it's a correct one with the answers on it. You see it?
Yes, sir.
All right, good. Big up on
Yes,
yourself.
sir.
Thanks for coming out here. Have a good one.
Yes, yes.
All right, cool.